So here, good evening. The question is the consider the execution of following instructions by 8085 microprocessor. MVI H01 FF SHLD 2050 hexa. Okay. Now the question is after execution of the contents of memory locations, after execution, the contents of memory locations 2050, 2050, 2050 hexa, 2050 hexa, and the registers H and L will be respectively. That is the question. So here MVI H from 01 FF. That means MVI solution. The MVI H comma 01 FF hexa. What does it mean? It is a 16-bit number. That 16-bit number is transferred to the immediate data. That 16-bit immediate number is transferred to the HL register pair. Okay, so HL register pair is loaded with the 16-bit number 01 FF. That means because of this is the higher order, this is the lower order. So 01 is loaded into H register, FF is loaded into L register. Okay. Next, SHLD 2050 hexa. What does it mean? That means SHLD 2050 hexa. Here, 2050 is a 16-bit memory location address. Into this address, the HL register contents are transferred to this memory location address. Okay. So that means because of HL register pair is having 16-bit number. So we usually two memory locations required. Okay, two memory locations are required. That is 2050 and 2051. Automatically it is incremented by 1. Now HL register pair contents are transferred to these two memory locations. First lower order memory location 2050. So L register contents are transferred to this memory location. So FF is stored into this memory location and it is incremented by 1. Memory location address is incremented by 1. H register contents are transferred to this 2051. That means 0. Okay. So now as per the question, after execution, the contents of memory locations 2050. So 2050 is FF and 2051 is 01 and HL register bits. See here, the HL register contents are copied or just stored into 2050 and 2051 memory locations. But the HL register pair contents remains the same in the registers. So H register is having 01 and L register is having FF. Now, as per the question, 20 is contents FF, 2051 is having 01, H register is having 01, L register is having FF. Okay, so this is the data. So now, based on this, option C 2051, 2050, 2051, H register and L register. So option C is the right answer. Okay. Next, another bit. Consider the following instruction to be executed by 8085 microprocessor. The input port here, the input port has an address of 01 hexa and has a register of data 05. Okay. So here the input port address is, this is input port. Input port address is 01 hexa and the data contained in this input port is 05 hexa. That means this represents address, this represents the. Okay. Now, what is the what are the instructions in 01 hexa? In 01 hexa, so what what is the operation performed here? That means 01 hexa is the input port. That input port will be identified. And the data contained in this input port is transferred to the accumulator. Is transferred to the accumulator. Okay, so that means accumulator is having the 05 hexa. Now A and I 80 hexa. A and I 80 hexa means end operation with the immediate data. End operation between accumulator contents and operated with the 80 hexa. Okay, and result is after end operation, logical end operation, the result will be stored again in the accumulator. Okay, so now accumulator contents are 05. That means 0, 0, 0, 0. 5 means 0, 1, 0, 1. Next, end operation with 8, 0. 8 means 1, 0, 0, 0. This is 0, 0, 0, 0. Okay, so now between these two, end operation. Okay, end operation. End operation between two bits. Already we know that end operation for 0, 0, 0, 1, 1, 0, 1, 1. Okay, end operation 0, 0, 0. If two bits are 1, then the output is equal to 1. So based on this 1, 0 is 0, 0, 0, 0, 0, 0. Okay, so the result is completely 0. So now what is the question? After execution of the above instructions, what are the contents of the flag register? Contents of flag register means what are the flags? Carry flag. Okay. Flags are carry flag, auxiliary carry flag, zero flag, parity flag, sign flag, parity flag. These are the data. Okay. In this, the carry is not generated. In this result, the carry is not generated. So that's why carry flag is equal to 0. Auxiliary carry is also not generated. Carry generated means at the MSB bit position, if the carries will be generated, then carry flag will be set, otherwise it is equal to 0. Auxiliary carry means at this position, if carry is generated, then auxiliary carry will be set. But here no carry is generated. So that's why auxiliary carry is also 0. Okay. And signed bit, it is not a signed bit operations. So that's why sign flag is also 0. Parity flag, there are no ones. Okay. So parity flag is equal to 0. But the result is completely 0. So that's why the 0 flag will be 1. Okay. So carry flag is equal to 0. Offset, there are totally 5 flags in 8085. 8085. Okay. 5 flags in 8085. 8085. So 5 flags, carry flag, outside carry flag, 0 flag, sign flag, parity flag. So carry flag is equal to 0, object carry is equal to 0, 0 flag is equal to 1 because of the result is a 0 result. Sign flag is equal to 0, parity flag is equal to 0. Okay. So hope you understand. Thank you.